All right, we are going to look at the idea of reference angles, which we already looked at with degrees, only this time we're going to look at that in relation to radians. So we're going to look at reference angles with radians. You might want to have your unit circle papers with you so that you have those to refer to. Some of this information, it'll be easier to find on that. You can kind of match things up. Okay, let's look at this one. If I'm going to change these radians into degrees, if you remember how to do that, to change radians into degrees, we multiply by 180 over pi, and then we try to cross divide as much as we can. So my pi's will divide away, and 6 goes into 180 30 times. That turns out to be my reference angle. However many times this one goes into 180, is going to give me my reference angle. We're only going to focus on 3 particular things, and this is the way all of them will work. So my denominator is going to give me my reference angle. My numerator is going to tell me which quadrant I'm in so that I'll know whether to use positive or negative when I do my trig function. Okay, so let's see what this is going to look like. All right, here we have our first quadrant angles. So 6 goes into 180 30 times. This is my reference angle of 30 degrees. If you want to think about it in radians, the reference angle is pi over 6. Here, 4 goes into 180 45 times, so my reference angle is 45 when I have 4 in the denominator. And 3 goes into 180 60 times, so my reference angle is 60 when I have 3 in the denominator. Okay, look at the numerators. See what the numerators have in common. Okay, well, it doesn't take much to realize that all of those numerators have pi. So in the first quadrant, write this on your paper, in the first quadrant, the numerator equals 1 pi. Okay, and that's going to be true of all the ones that we do in the first quadrant, that the numerator is going to be equal to pi. Now, there are infinitely many radian angles moving across here. I'm not saying this is true of every radian angle in the first quadrant. I'm saying this is true of the ones that we are going to focus on in the first quadrant. Okay, so I'm going to have 1 pi as my numerator for all of these. All right, let's move over to the second quadrant. Look, the denominators don't change. My reference angle is staying the same. So here 6 goes into 180 30 times. My reference angle is 30. 4 goes into 180 45 times. That's my reference angle of 45. 3 goes into 180 60 times. That's my reference angle of 60. Now let's figure out what's going on with the numerators. Look at the numerator. Look at the relationship between the numerator and the denominator. Okay, if you notice in this quadrant, the numerator equals the denominator minus 1, and then there's a pi after that. Denominator minus 1 times pi. So 6 minus 1 is 5, 4 minus 1 is 3, 3 minus 1 is 2. So why does that work? Okay, well, if you think about it, when we went around the unit circle this direction, remember we said we were measuring our reference angle from the horizontal. Right here, this is 180 degrees. 180, if I change that into radians, is going to be pi, right? Remember we said 180 and pi are the same. That's why we have that multiplier to change radians to fractions and radians to degrees and degrees to radians. So when I have pi right here, this is the same thing as 1 pi, right? Understood 1 in front of it. So I could write that, for example, as 6 pi over 6. 6 pi over 6, 6 over 6 is 1. So 6 pi over 6 is the same thing. So if the black dot is 6 pi over 6, the blue dot is 1 pi over 6 away from it. I didn't quite get there. I'm 1 pi over 6 short. So that's why the numerator here is 1 less than the denominator. 6 minus 1 is 5. And I could do the same thing for the other ones if I wanted to. Let's look at what happens when I do 4. So pi is the same thing as 4 pi over 4. And I didn't make it all the way to the black dot, right? I didn't make it all the way to 4 pi over 4. I'm up here at the red dot. I'm 1 pi over 4 away. So I have to subtract 1 because I'm 1 pi over 4 away. 4 minus 1, 3 pi over 4. Okay, so in the second quadrant, the numerator equals the denominator minus 1 times pi. Okay, let's see what happens in the third quadrant. All right, look in the third quadrant, same 3 reference angles, 60, 45, and 30. But this time, what do you notice about the numerators in relation to the denominators? All right, well, this time the numerator equals the denominator plus 1 times pi. All right, denominator plus 1, right? 6 plus 1, 4 plus 1, 3 plus 1. Okay, so same kind of idea. Let's do the 3. Let's do the 60-degree angle this time. So if I'm at 3 pi over 3, that's the black dot right here. And to get to that green dot, I went one more piece, one more pi over 3 from the black dot, giving me 4 pi over 3, because 3 pi over 3 plus 1 more pi over 3 would be 4 pi over 3. So here in the third quadrant, the numerator is always equal to the denominator plus 1. All right, let's move into the fourth quadrant. Okay, so this one is a little bit trickier. I've got those same 3 reference angles, 60, 45, and 30, right? Because 6 goes into 180 30 times, 4 goes into 180 45 times, 3 goes into 180 60 times. So I'm trying to get up to this black dot because I always do my reference angle from the horizontal, right? The black dot is 0 or 360, which in radians is 2 pi. You guys remember that from when we did our our coterminal angles. We would add and subtract 2 pi. So in the first quadrant, we're measuring from 0. Here in the fourth quadrant, we're measuring from 2 pi. Okay, so let's do the same kind of thing we did with pi. I've got 2 pi over 1, and let's suppose I'm trying to do this one. Okay, I'm going to need to multiply top and bottom by 4 so that I have a common denominator. I've got 8 pi over 4. So how much away from 8 pi over 4 is 7 pi over 4? Well, you subtract 1 because I'm only 1 pi over 4 away from making it all the way to 2 pi, all the way around the circle. I just didn't quite make it. I'm 1 pi over 4 short. So if I take the denominator and I multiply by 2, because I'm trying to get right here to 2 pi, and then subtract 1 because I didn't quite make it, I'm 1 short. Okay, so let's write that down. In the fourth quadrant, the numerator equals 2 times the denominator minus 1 times pi. All right, and I'll move that 0 out of the way so it doesn't mess you up. Okay, the numerator, 2 times the denominator minus 1 times pi. And this is the reason, because this time instead of trying to get to pi like we were over here at this black dot, we're trying to get to 2 pi at this black dot. So we take 2 pi, multiply, and subtract. All right, now let's go backwards on the unit circle. Let's do some negative angles. So if I am here and I am moving in a negative manner, let's go back to this being 0, and I'm moving in this direction. Do you see that the blue dot here and the blue dot here are the same distance away from 0? It's just that this one went in a positive direction and this one went in a negative direction. So when I move down, I'm going 1 pi over 6 away from 0. It's just that I'm moving in a negative direction. So I'm going to have those same reference angles, but I'm going to be moving in a negative direction. So when I'm going in a negative direction, the numerator equals negative 1 pi. Because instead of going up 1 pi, I'm going down 1 pi. I'm just going in the opposite direction. Okay, now think about this for a second. This is 1/4 of the unit circle. If I move into the second fourth of the unit circle, I realize I'm in the third quadrant, right? 1, 2, 3, I'm in the third quadrant. But moving away in a negative direction from 0, I'm in the second section that I would get to from 0. So what do you think is going to be true about these 3? All right, they're going to be the same as what I had here. It's just the signs are now all going to be negative. Because when I'm moving in a positive direction, I went 2 quadrants away from 0, 1, 2. When I'm moving in a negative direction, I am also going 2 quadrants away from 0. I'm just going the opposite way. So the distance from this black dot around the circle to this blue dot, or from this black dot around the circle to this blue dot, the distance is the same. It's just the direction that's opposite. So that's what those negatives tell me there. So if I were to write something here, I would say denominator minus 1, and then the whole thing has to be negative. Okay, because it's these same things, just the opposite sign, because I'm going the opposite direction. All right, let's move into the second quadrant. Okay, so here in the second quadrant, you can see that I am 1, 2, 3 quadrants away from 0. So basically the ones that were here just flipped up here and all the signs changed to negative, just like what happened before. So I'm now plus 1 because I'm going in the opposite direction. I made it all the way to negative pi, and then I went 1 pi over 7 or 1 pi over 6 again in a negative direction. So negative 6 pi over 6, and then one more negative pi over 6 gives me negative 7 pi over 6. So if I'm moving in a negative direction, those are the angles that I would have gotten. Last quadrant, over to quadrant 1, which if you look at it, this is 1, 2, 3, 4 quadrants away from 0 in a negative direction. I am in the first quadrant. Don't say this is the fourth quadrant. This is the first quadrant. It's just that I have moved 1, 2, 3, 4 in a negative direction. So down here, remember, it was denominator times 2 minus 1. So now I'm going to do denominator times 2 minus 1 and then make it negative because I'm going in the opposite direction. So write those 3 down, going in the opposite direction. Okay, let's look at our quadrantal angles. As you can see, as I'm moving around the black dots, each one of those is 90 degrees, right? If I take my whole 360 degrees of my circle, cut it into 4 pieces, each one is 90 degrees. So 90 goes into 180 2 times. So that's sort of like my reference angle right there, looking at a 90-degree angle. And then if I go 90 more degrees, pi over 2 plus pi over 2, that's 2 pi over 2. Well, that's the same thing as 1 pi because 2 over 2 is 1. And then 2 pi over 2 plus 1 more pi over 2, that gives me 3 pi over 2 down here at this dot. And then if I go pi over 2 again, 3 pi over 2 plus pi over 2 is 4 pi over 2, and 4 over 2 simplifies to be 2. So that's where I got the 2 pi. So when I'm moving in a positive direction, I'm basically counting forwards by pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. All right, let's go the opposite way. So now I'm still counting by pi over 2s. It's just that I'm counting now in a negative direction. So negative 1 pi over 2, negative 2 pi over 2, negative 3 pi over 2, negative 4 pi over 2. And they simplify exactly the same. Negative 1 pi over 2 stays as it is. Negative 2 pi over 2, 2 over 2 is 1, so negative 2 over 2 would be negative 1. Negative 3 pi over 2. And then over here, negative 4 pi over 2, 2 over 2 is 2. I'm sorry, 4 over 2 is 2. So this time it's negative 2 because it's negative 4 over 2. Negative 4 pi over 2 simplifies to be negative 2. So notice that in this case, the ones on the y-axis flip-flopped, but the ones on the x-axis stayed where they were. They just changed their sign. Because if I go this way, 1 pi over 2, 2 pi over 2, or if I go this way, negative 1 pi over 2, negative 2 pi over 2, it still simplifies to be either pi or negative pi. It does not simplify to be 2 pi. It doesn't flip-flop this way. It only flip-flops this way because we're changing the direction. Okay, let's do a couple of practice problems. Look at this one. So if this were a quiz and I were to ask you what is the reference angle, remember to find the reference angle, I look in the denominator. 4 goes into 180 45 times. So my reference angle is 45. You can think of this in degrees as a reference angle of pi over 4. In radians as a reference angle of pi over 4 if you want to. But for most people, thinking in degrees is easier. And then I see that 5 in the numerator. Well, 5 is 1 more than 4. And the quadrant where the numerator is 1 more than the denominator is the third quadrant. Okay, this one down here, reference angle of 60. 3 goes into 180 60 times. Now the numerator is 2 times 3 minus 1, but it's negative. So that means I went 4 quadrants this way, which puts me back in the first quadrant. So negative 5 pi over 3 is a first quadrant answer.